So now that we've reviewed rules for how to count the number of significant figures in a measurement and looked at rounding, let's look at rules for significant figures in calculations. So most important thing to remember is that the rules for addition and subtraction are different from multiplication and division. When you look at addition and subtraction, the only thing that matters is where the uncertainty is relative to the decimal point. So for example, if we look at two volumes that we're going to add together, the uncertainty in the first measurement is in the tenths place, right? And the uncertainty in the second measurement is in the hundredths place. So when we add these together, the measurement that's going to define where our uncertainty is in the tenths place, because this one is what I would call a cruder measurement. Okay, there's less information here than in this one. So when we put this into our calculator, we get 106.78, but right there is where our uncertainty is, and it's defined by this number here. So when we go to round, we need to round to where this digit is, so it's 106.8 should be our final answer. It's important to note that it does not matter what the number of significant figures is for the measurements. I mean, this one's 3, right? And that one is 4. That's immaterial. It's where the uncertainty is when you do the addition or subtraction operation. If we look at subtracting two volumes, this is even more extreme. The uncertainty in the first measurement is in the tenths place, and the uncertainty in the second measurement is in the 10,000ths place. So essentially, I'll tell you, you would never want to do this in the laboratory where you take such an ill-defined measurement here with such an incredibly precise measurement here, because you're going to lose all of this information. It's going to be gone. So when you add these together, your uncertainty is defined by this measurement, the cruder measurement. We know it only to the tenths place. So that's where you need a round. So this will round up to 863.1 milliliters. Now, when we go to multiplication and division, the rule is whichever measurement has the fewest significant figures, in this case we have 2, 2, and 4, we round our final answer to whichever one of these has the fewest significant figures. So let's go ahead and multiply this out, right? And we're going to round to 2 significant figures. So you're going to lose all this information. You'd round down to 23. So again, when you're doing these problems, it's easy to get these two confused. So you're going to want to do enough problems dealing with this so that you don't get these two rules mixed up. Now let's look at a multi-step calculation. You need to keep track of your order of operations. So in truth, you need to do everything in parentheses first. Then after that, the order of these three operations doesn't really matter because it's all multiplication or division, right? This is multiplication, multiplication, this is division, where the order of operations doesn't matter. But they must be done before addition, subtraction. When you're doing addition and subtraction, the order here doesn't matter either, but this must come after multiplication and division. So you can use this acronym if you want to keep this straight. Now, here we're faced with, this has 4 significant figures, 3 and 2. And we must do the subtraction first instead of the multiplication because all of this is in parentheses. So when we do this part of the calculation, we use the addition-subtraction rule. Our uncertainty is in the tenths place here, it's in the hundredths place here. So we do the operation, and we get 3.37. Now, I've underlined the 3 to recognize that this number only has 2 significant figures in it. The reason why we don't round yet, we'll come to that in a moment. You don't round an intermediate answer. When you do this in your calculator, you'll have a 3 and a 7 there. But the point is, you want to keep track of where the uncertainty is. So if you have it in your calculator, just remember that this number actually is 2 significant figures, and would be if you were to round it to 3.4. You just don't do it yet. Now you take this value, you multiply by 3.489, and now you use your multiplication division rule. This is 4 significant figures. This one is not 3, it's only 2, right, because of this operation. So when we multiply these together, we get 11.757932, but we need to round to 2 significant figures. So it rounds up to 12. And when you take your test, you're going to be examined on an individual addition, subtraction, or a multiplication rule, but you'll also be given a problem where these are combined together, like in this situation. So ultimately, you need to be able to do this for the test. Let's look at one more example. Imagine that each one of these it comes from a measurement, where this one is 5 significant figures. This is 1. This is 3, that 0 being significant. This one is 4, and this one is 3. Now, where do you start? You start right here. These two numbers are multiplied, and then we divide by 96. So you need to do this first. So we need to apply our multiplication division rule. So which one of these has the fewest significant figures? Well, the answer is 3. These two have 3 sig figs. So we get this result in our calculator. We underline the third significant digit. If we were going to round, we would go ahead and round here, but we never round in an intermediate part of a calculation. You never round till the very end. So at this point in our calculator, we would take this value, recognizing that this is 3 significant figures, and now we do the addition-subtraction rule. There's our uncertainty in this number, right? That's the last significant figure. This is the uncertainty in our number here. So this is a thousandths place, this is a hundredths place. Our uncertainty here is in the thousandths place. So it's this measured value that we need to round our final answer to the hundredths place. So we get this value in our calculator, we round to the hundredths place, and then we round down. This all goes away, and we end up with 11.15 as our final answer. And then as final comments on dealing with significant figures and calculations, just a couple of things to remember. This value has no decimal point after the 0, so this has only 2 significant figures. If we put the decimal point in, our uncertainty is in the ones place. So we have 3 significant figures here. You can always convert to scientific notation. So if I move this decimal point over 1, 2, 3, 4 places, right, I need to divide by 10 4 times to keep the number the same. So that becomes 3.9600 times 10 to the minus 4. These zeros are significant. We have 5 significant figures in this value. Exact numbers we do not enter into our thinking for dealing with uncertainty and significant figures in a calculation. So if you had the number 4 in any of the calculations we've looked at, and it's not part of the measurement, it doesn't go into our thinking about dealing with significant figures. And then finally, we showed you 2 examples of a multi-step calculation where we keep track of the number of significant figures in an intermediate answer, but we don't round it yet. We only round off on the final answer, and the reason for that is to remove bias and what's called round-off error in the final answer.